Today we're going to look at the idea of proportions. Now that we've talked about ratios and we know what a ratio is a comparison of two quantities. Now we're going to get into the idea of proportions and proportional reasoning. A proportional reasoning rather means when you take a ratio and you come up with an equivalent ratio that helps you still to compare those two items but in different quantities. So a proportion is when we have those two ratios that are equal. Basically, it's a lot like equivalent fractions. So the way that we would know that they're equal, one way is we would know that their cross products would be equal. So for example, we could look at a ratio of 2 to 3 and a ratio of 4 to 6 and know that those two ratios are equal because 3 times 4 is 12 and 6 times 2 is 12. So since those two have equal cross products, that means they must be equal. This one is also pretty easy to look at because you should be able to look at it and see 2 times 2 is 4 and 3 times 2 is 6. So that shows us that a ratio of 2 to 3 and a ratio of 4 to 6 are equal. Now, could we have written these ratios like this? 2 to 3 and 4 to 6, 2 to 3, and does it equal 4 to 6? Yes, we can absolutely write it that way. The thing about writing it that way is you have to understand that most of the time it's probably going to be easier to work with those once you write them in fraction form because you've done other things probably before with fractions that are going to make that easier. So another thing you could do to see if two ratios are equal is you actually could draw a picture of them. So I can look at a ratio of 2 to 3 and I can look and see what that means is in this picture, for example, for every 2 green circles, there are 3 red triangles. Well, when I look at putting another group of 2 green circles and 3 red triangles, notice that still now gives me a ratio of 4 to 6. Notice that that ratio of 4 to 6 has 2 smaller groups that are each 2 to 3. That shows me that the ratio of 2 to 3 and 4 to 6, that those two ratios are equal. Therefore, they do form a proportion. So let's look at another example and see if these form a proportion. Our next example is a ratio of 3 to 5 and a ratio of 20 to 25. Do they form a proportion? So let's check. Let's use our cross products method to check and see. Okay, when we do our cross products, 5 times 20 is 100. And 3 times 25 is 75. They are not equal. Therefore, a ratio of 3 to 5 is not equal to a ratio of 20 to 25. So those do not form a proportion. And I could also look at this visually and see if I have a ratio of 3 to 5, that's 3 yellow circles to 5 purple triangles, and I try to use groups of ratios of 3 to 5 to see if I could make it a bigger group, keep repeating it to see if I have a bigger group of 20 to 25. As I do that, I now have a ratio of 6 to 10, 9 to 15, 12 to 20, and 15 to 25. So notice if I had 25 purple triangles, I could only have 15 of the yellow circles. So that tells me that a ratio of 3 to 5 is actually equal to a ratio of 15 to 25, not 20 to 25. So that's another way that I could see, do those two ratios form a proportion? And no, they don't. They are not proportional to one another. So take a moment to look and see if these ratios form a proportion. All right, now that you've had a chance to look at it on your own, the first one, a ratio of 4 to 6 and a ratio of 16 to 24. You probably looked at pretty quickly and said, well, yeah, because I can multiply both the 4 and the 6 by 4, and that gives me a ratio of 16 to 24. You also could have used cross products. 6 times 16 is 96, and 24 times 4 is also 96. So the cross products equal, therefore those two ratios are equal and form a proportion. The second one you might have looked at and said, no way, those aren't equal because I can't do 8 times anything and get 20. Well, yes and no. You can't do 8 times any whole number to get 20. So you might not use that method of just seeing, can I multiply both 2 and 8 by a common factor to get a ratio of 5 to 20. In this case, your cross products method is going to be an easier method to use. 8 times 5 is 40. 20 times 2 is also 40. So since 40 equals 40, then yes, those two ratios do form a proportion. So notice that you don't always have to have a whole number relationship, meaning, for example, I didn't have to have a whole number that I can multiply 8 by to get 20. There is a common factor that I can multiply both 2 and 8 by to get 5 and 20. It's just not a whole number. It happens to be 2 and a half. 2 and a half times 8 is 20, and 2 and a half times 2 is 5. So there actually is a common number that I can multiply 2 and 8 both by to get 5 and 20. But the cross products method is probably easier when that's not a whole number factor. Now, another thing that we're asked to do with proportions is, if we're given one ratio, we're asked to find an equal ratio given what one of the numbers is. So, for example, this one's saying how many triangles must there be to make a proportion? And then how did you know? So when we look at this, there are 3 green circles, and there are 4 red triangles. So this shows a ratio of 3 to 4. And then we want to know, well, what would be a ratio equal to that that would have 9 red circle or 9 green circles instead of 3. Another way you might set this up is you might set this up using a bridge map. A bridge map would tell you the number of circles compared to the number of triangles. And what we know is for 3 circles, there are 4 triangles. What we want to know is, if there are 9 circles, how many triangles must there be? I'm going to use a variable for that. I'm going to use x. And again, this is the same thing as saying a ratio of 3 to 4 is equal to a ratio of 9 to x. This one's pretty easy to solve. I should be able to look at it and say, oh, well, if I have 3 times as many circles, then I need to also have 3 times as many triangles. So if there are 9 circles, there needs to be 12 triangles. So in this case, x is 12. I have to have 12 triangles, and that's how I can prove it. I need to be able to do that without necessarily drawing a picture. If you need to draw a picture, that's okay to do. And we really just did this last one. It's really similar to writing equivalent fractions, which we just did, but I want to also show you another way that you can do it. You can also do this algebraically. We know that when we're writing equivalent fractions that they're going to have cross products that are equal. So we should be able to look at this and say, well, what that means is 4 times 9 has to be equal to 3 times x. So then I can say, well, if 3x is equal to 4 times 9, 4 times 9 is 36. Remember what we know about solving equations. Use opposite operations and cancel to figure out the value of your variable. So x had to be 12. We could figure it out that way. Another example of this, a ratio of 4 to 7 is equal to a ratio of m to 56. Well, I need to set this up in fraction form, otherwise I'm not going to be able to work it out. A ratio of 4 to 7 is equal to a ratio of m to 56. I could work it out without doing that, but it's going to be a little easier this way. A couple different ways I can do it. Probably the quickest way when you look at this one is to say, oh, 7 times 8 is 56. Therefore, 4 times 8 is 32. So m must equal 32. That's one way you could do this. Now, the next one that we're looking at, a ratio of h to 12, again, I want to write this as in fraction form because it's going to be easier, is equal to a ratio of 10 to 8. There's no whole number that I know that I can multiply 12 by, multiply or divide it by to get 8. So I'm going to look for another method. And this is where I'm going to get into my algebra method. I'm going to get into seeing that, well, I can use cross products here and do 12 times 10 is one of my cross products, and 8 times h. And I know that in a proportion that the two cross products have to be equal. So this is telling me 8h equals 12 times 10, which is 120. 8 times h, I need to use the opposite of multiplying by 8, so I'm going to divide by 8 on both sides of the equation, giving me that h equals 15. So in other words, a ratio of 15 to 12 is equal to a ratio of 10 to 8. And my next one, a ratio of 5 to 15 is equal to a ratio of 9 to R. Again, I don't really see a way to multiply 5 by a whole number to get 9. So I am going to use my cross products. And when I do that, I'm going to need to do 15 times 9, which is 135. And then I'm going to need to do 5 times R. So we're going to get 5R equals 135. So I'm going to need to divide by 5 on both sides of the equation. And if you need to, it's absolutely okay to work out your division. 135 divided by 5 is going to give us 27. And that's, again, perfectly okay to do. So in this case, a ratio of 5 to 15 is equal to a ratio of 9 to 27. Now, something interesting to note about that, and this is always going to be true with ratios as well, if they can be simplified easily. So 5 to 15 equals a ratio of 9 to 27. If you look at each of those ratios independently, you probably should be able to look at those and see, a ratio of 5 to 15 is equal to a ratio of 1 to 3, and a ratio of 9 to 27 is also equal to a ratio of 1 to 3. So since they're both equal to a ratio of 1 to 3, that means that those two have to be equal and therefore form a proportion. So again, looking at proportions is an awful lot like looking at writing equivalent fractions. We use a lot of the exact same techniques. The difference is going to come about when we start putting those in word problems.